All right, so you have some cards, you're sharing them with your group. What I want you to do is I want you to find the card that is labeled as B. Looks like this. And this card, it's not a function, it's called a relation. It's just a couple points. And the way that we write a relation, you do not have to write this down unless you want to write it on notes or something. You don't have to write it on a sheet. But if I was to call this a relation, I might say, I think people still do f of x, but we could say y, or not even y equals. I've seen them just write relations like this, and they would write down the points. So this would be the point 2, 1, and then we've got the point 3, 3, and then we've got the point 1, 4, and we've got the point 4, 4, and they would say that's the relation. Does that make sense? Okay. So if we want to write the domain of the relation, then that's saying what are the x values that get used. And it's not like, oh, we're using x values from 1 to 4 because we're not using any of those decimals. We are only using whole numbers. So what are the specific x values that get used in this relation? So if we put them in order, what would the first number be? 1, and then, okay, and then 4. Okay. And if we wanted to say the range of the relation, what would the range be?
I would just be writing that down in
Oh, sorry. I wrote it on the wrong one. You were right. B.
Yeah.
Yep, and you guys are sharing it with your group. And then what's the range? Just 1, 3, and 4. And notice that the value of y, that's 4, it happens twice, but I only wrote it once. Because for the range, I'm just saying what are the y values you can have. You can clearly have 4 because you had it twice. But you don't have to write it twice. Okay. All right. Now what I want you to do is I want you to look at the other cards and I want you to see where you can find the inverse. So if these are the points of the original relation, then what points should we see for the inverse?
1, 2, 3, 3, 4, 1, and whatever one is.
4, 1, 4, 4. Okay, so go ahead and see if you can. Did you guys like my squiggly bracket there? It looks good, huh? It's pretty good. Did a good job. You guys were supportive. I like it. All right, so look for the relation that has those points specifically. It can't have any other ones. It just has those. So looking at the pictures of your cards. Oh, I just dropped a bunch of my cards. Is it L? Is it E? Is it C? Is it G? Is it H? It's H? Okay. So if you look at H, we have the point 1, 2. We have the point 3, 3. We have the point 4, 1, and we have the point 4, 4. So this is the inverse relation because it has the inverse of each of those points. Does that make sense? All the x's and y's have been traded. Okay. So those two are a pair. B and H match up. So I'm going to go ahead and over here I'm going to write H. It matches with H. And then if I want to write the domain of H, what are the x values that we see for H?
You would just write the range of the inverse of that.
Okay, so the range for B, the y values for B, become the x values for H because they're inverses of each other. Okay, so we're going to say the domain of the inverse is 1, 3, 4. All right. And then what's the range of the inverse? 1, 2, 3, 4. Okay. So you can put those cards off to the side. Those are done. We matched them. Let's go ahead and we can grab table 4. Table 4. Okay. So if we look at table 4, I can see that the domain is what? Yeah, and let's go ahead and put them in order. So negative 8 is the smallest. What comes next? Okay. And then what are the y values? What's the range? Okay. So go ahead and find the table that is the inverse of table 4. So the x's and the y's need to have traded. They don't necessarily trade in the same order, so the table could be a little bit mixed up. But it looks like they are in the same order. Okay, anyone find it? Table 6. So if we look at table 6, it's just exactly the flipped version, or the inverse version. Okay, so what is the domain of table 6? What's the domain of the inverse? Okay. And then, so the range of the original function, or the original table, is the domain of the inverse. The domain of the original table is the range of the inverse. So this is really just forcing us to practice that idea that with inverses, the x and the y values trade. And that's all we have to do. We don't have to do anything complicated. We just have to make the x's and the y's trade. That's all we got to do. Okay. Let's go ahead and look at card A. How do we write the domain of card A? Zero to infinity. What do I know about the 0? You include 0. It's the vertex. So what does it get? Bracket. Perfect. Okay. What about the range? Negative infinity to positive infinity. What's going to be a good method for finding the inverse of this one? How do we find inverses? We swap x and y. So if you can find some points on this graph and then swap them, then you can figure out what the inverse is. I don't know. That's a great question. Hold on. My answer to you. It is J. It is J. Let's look at J. Okay, so here's the inverse. So what is the domain of the inverse? Okay, and what is the range of the inverse? 0 to infinity. Okay. Does it make sense what we're doing?
Yep.
Okay, go ahead and get started on that. Call me over when you think you've got your answer. Okay, so, oh, thank you. So if we were writing down, okay. If we were writing down some problems in function notation, we might have the point like f of 7 equals negative 2. And then if I were to think of that point, how could I actually write it? 7, negative 2. So that is function notation for saying that you have an x value of 7 and a y value of negative 2, or that if you plug in 7 for x, you get negative 2 as the output. So if we want to talk about the inverse, what would the inverse of that point be? Negative 2, 7. And so if we were to do this in function notation, I would say f inverse of -2, because now the -2 is the input, and what's the output? 7. So when you're doing these problems now in Math 3, now that we're comfortable with function notation, we're not going to write the points in this in-between version anymore. Now we're going to say this is the original function, this is the inverse function, and we're writing those answers like points. It's not wrong to write them like points, kind of the old school way, but this is function notation, and it's a little bit weird, so it's good to practice it. Does that make sense? Okay, so if I said g inverse of 5 equals -4, then how could I rewrite that point in function notation as an inverse of that? So g of -4 equals 5. So if that was the inverse, then this is the original function. So we're just going back and forth between those. Does that make sense? Okay, so when you start the packet after the activity, this is the notation that they start giving you the numbers in, instead of writing them like points. And if you need to write it like a point to make more sense of it, that's totally fine. I'm okay with you writing them like points, okay? But after you write them as a point, go ahead and practice writing this notation because it's good notation to get comfortable with. Sound good? Okay.